Okay, now we are going to talk about doing division, right? And we're talking about dividing functions, right? Function composition, dividing functions. So when we divide functions, it's the same thought process as the multiplication process, right? So in this one, we said that this is f of x times g of x, right? And we're using the dot product, so we don't have like a billion like parenthesis signs and stuff going on. Here, it's the same thing, right? You split it up, and this is basically the same way as saying f of x divided by g of x. And what's great about this one is that it literally looks exactly like that, except for the fact that you're just basically picking up f of x, setting it right here. You're picking up g of x, and you're setting it right there. So like this, right? We have f of x. Let's take that and just basically copy it down, right? Just like that. X squared plus 7x plus 12 all over 3x minus 4. And then in most cases of what we're going to be doing, you are finished. That is what you have to write for that, and you're in good shape. Now, what is different and complicated, or not complicated, but new about dividing with these is that we have to remember a very important thing with division, all right? And the most important rule with division, really, that I think we all know, but we got to remember, is that you can never divide by 0, right? You cannot do that ever. You just can't do it. So what we have to, how that affects us, is what that means is this right here, your denominator, right? Your denominator can never be 0. It can't, right? It can't happen. So the way we deal with that is we set up a we set up a little equation to see what the cases are when this would be 0. All right, and you'll see what we're going to do with that. So we're going to take this, right, and we're going to go, okay, we have 3x minus 4. There's only one factor here. It's just this. 3x minus 4 equals 0. So where this equals 0 is a no-no, right? So we go 3x minus 4 equals 0. We're going to add 4 to both sides. You get 3x equals 4, and then you divide both sides by 3, and we get x equals 4/3. So this is the spot right here that we cannot have happen, right? We can't have that. So the way we set that up is if we know that x can't be 4/3, but it can be everything else, we put that in our domain because that's where it's covered, right? So when we write our domain, right, and we write it the normal way with the curly brace and our line going down, all we have to do is just put this one contingency, or 2 or 3, depending on how many factors there are, where it does make the denominator 0, in which case we cannot include that point. So the way we write that is you write x equals 4/3, and then what you're going to do, some of you are familiar with this and some of you aren't, is you're going to draw a line through your equal sign. And what that means is x cannot equal 4/3. So what this basically says is, hey, x is all real numbers except for 4/3. All right, that's how this reads. All right, reads. All right, x is all real numbers except for 4/3, right? And it's a very specific case, right? 4/3 is a specific number, and that's how that works, and that's how we approach this, okay? And that's the easiest way to think about this, right? And now, okay, now what we're going to do is we're going to look at the range, and the range for this is kind of crazy. All right, so let's put this in, and I have it entered in already. So I'm going to get rid of this one. We'll put this one in, and then I'm going to pull this down, and you're going to see something really wild going on here. All right, so what we have first of all for our x values, right? If I kind of pull this out a little bit, is even though it's hard to tell, right here at 4/3 we have something called an asymptote. And what an asymptote is an asymptote is a straight line which basically both sides of the graph approach but never touch. Okay, so that is covered by this. That's covered by this x cannot equal 4/3. So that would give you your asymptote, all right? Asymptote at x equals 4/3. All right, so it's basically a line that goes up and down, right? That the graph will get closer and closer and closer to, right? But it never touches. Okay, so that's how asymptotes work, right? And that is covered in your domain. However, we also got some other crazy things going on here. And the other crazy thing going on is if we blow this up a little bit, which I will do, you will notice that this thing has, these things have high and low points, right? So the highest this thing gets on the left side, right, is 0.017, right? 17 thousandths of a unit, okay? And then here, the lowest this thing gets is 6.427. So we have to, basically, there's this no man's land that's kind of between both of these, right, where there are no numbers. There are no y values included in this composition of this function, right? So we have to notate that somehow in the range. And so I'm going to show you how to do that. And so the way we are going to do that is for range, we are going to say, okay, well, first of all, we're going to use our y, right? So let me make sure we got this. So you go equals, and this is going to be a little longer to write. All right, the first one we got to look at is we know that y has to be less than or equal to this point right here, to this 0.17. And you can just click on Desmos and it will tell you what it is, 0.017, sorry, my bad. So it would be y is less than or equal to 0.017. And then we're going to use the word or y has to be greater than this one right over here, which was 6.427. Okay, and really, honestly, that's it. And then, so what this says, all right, then the way this reads is y is basically can be everything as long as it's less than this number and greater than this number. So in the grand scheme of things, this isn't a very large span. It's you know, it's about 6 point whatever that is, right? 6.4 or 1.4, something like that. So not even 6.5 units where you can't have y values, and everything else works, but we have to notate that so that we understand that there's nothing in there. So if somebody says, well, y is 3, we could be like, well, that's impossible because it's not included in this. So this basically tells you that, hey, you know, everything below 0.17 and everything above 6.427, right? This is all good. This is all good right down here. And then this part right here is no bueno. All right, and so that's what you want to show in your range. This is how you write it, and really that, like I said, that's the most complicated thing about doing these. It's just making sure you're getting your domain and range right with the division aspect of it. Okay, so hopefully this helps. It's basically just kind of look at the graph and just use your common sense and how you know how to write inequalities. We showed you how to account for the contingency, right, of one that that doesn't work, right? Makes your asymptote. So yeah, so hopefully this helps. All right, we will see you. We got one last video coming up.